Hi there, Javier here, and welcome to the first video on my TheSciencePundit YouTube channel. This is going to be a video about math, kind of in the theme of some previous videos of math I've done on my other channel. Today I'm going to be looking at the famous trigonometric identity sine squared x plus cosine squared x is equal to 1. Now I saw this come up recently in a comment by Heather from Frog Splat Science that she wrote on a video by Taylor from Redshift Science about beautiful equations, and I think this indeed is a beautiful equation. In fact, I'm going to be making this a response to that video, so you can see it here, and I'll also put the link up here. So let's look at this. Sine squared x plus cosine squared x equals 1. To start off our examination of this, let's review what sine and cosine actually mean. And to do this, we're going to need to draw a right triangle. So let's go ahead and get our little straight edge and corner here, which I'll be using my IKEA catalog for that. We'll draw here, here, and then there. Okay, here's our little right triangle. That's the right angle. Kind of an ugly right angle, but it's a right angle. And then beside opposite the right angle is called the hypotenuse. And let's call this little angle here x. Now, the side opposite x we'll call O for opposite, and the side adjacent x we'll call A for adjacent. Now, sine and cosine. The sine of the angle x is defined as the opposite divided by the hypotenuse, O divided by H. That is the definition of what sine is. And then the cosine of x is equal to the adjacent divided by the hypotenuse, or A divided by H. Now, if you wanted to keep going, we have the tangent of x would equal the opposite divided by the adjacent. And there's all sorts of mnemonic devices for remembering what they are. The one I was taught in school was Oscar had a heap of apples, but there are others. Now, what makes this important, and it makes it important for like, say, a lot of science, like physics. You couldn't do physics as we know it without trigonometry, because what you're able to do is you're able to take any triangle and determine with just an angle and then one side, you can determine what the entire triangle is. And this can help you determine trajectories, velocities, all sorts of things. Like I said, physics without trigonometry, impossible. And just to give you an example of how you can do rearrangements, here, using this definition, we know then that the opposite, the side O, is equal to, by multiplying both sides by the hypotenuse, H times the sine of x. And likewise, the adjacent equals H times the cosine of x. So that way, if we know the hypotenuse and we know the angle, then we can figure out what the adjacent side is and what the opposite side is. That's because we know those values, because there's tables for sine and cosine. Anyway, getting back to the triangle. Since this is a right triangle, it follows the Pythagorean Theorem. Incidentally, if you haven't seen Pino's video, Pino from Rosebushi, where he proves the Pythagorean Theorem by cutting out little pieces of paper, really neat video. I'll put a link to it up here. What the Pythagorean Theorem, of course, says for a right triangle is that if you take, say, one side, the opposite side, square its length, add to that the square of the adjacent side's length, that adds up to the square of the hypotenuse's length. So you have O squared plus A squared equals H squared. But now we can use our definitions of little rearrangement here, trigonometric identities, and we know that O is equal to H times sine squared x, or H times sine x, I'm sorry. Never mind that. So O, we're going to have H times sine x and that's squared, plus a is h times cosine x, and that's squared, is equal to h squared. Now since h times sine x is a product, we can distribute the squaring, and we have h squared times sine squared x. We put the squared over the sine to say that we're squaring the entire sine. In other words, we're taking the sine of x and squaring that. If we were to put the 2 out here, that would mean that it's the sine of x squared. In other words, we're squaring x, then taking the sine, but that's not what we're doing here. We're squaring the whole thing. And we do the same thing over here, and we have h squared times cosine squared x is equal to h squared. We can factor out the h squared. We get h squared times sine squared of x plus cosine squared. Kind of clumsy today. Cosine squared x equals h squared. Divide both sides by h squared, and we get sine squared x plus cosine squared x equals 1. So, there you go. That's where it comes from. And that we have just proven that this trigonometric identity is true for all x, where x represent angles in a right triangle, so angles between 0 and 90 degrees, or 0 and pi divided by 2 radians, if you're working in radians, not counting 0 and pi over 2. Although I will tell you right now that the identity does hold true for all x. However, I'm running out of time, so that proof will have to wait for my next video. So anyway, hope you enjoyed it. Science Pundit, out.